Hello, my friend. Welcome to my Fall Asleep channel, a place created for calm, rest, and gentle nights. If you enjoy peaceful stories like this, you are warmly invited to subscribe and return whenever you need to slow down. Now allow yourself to get comfortable, let the day fade away, and enjoy a quiet and pleasant rest. Let's begin. Earth is a small planet moving quietly through a very large universe. It formed about 4.5 billion years ago from dust and gas left behind by older stars. Those particles slowly gathered under gravity, growing warmer and denser until rock formed and a world took shape. From the beginning, Earth was never alone. It became part of a solar system, a family of planets orbiting a single star, the Sun, a star that formed from the same cloud of material, igniting nuclear fusion at its core, releasing light and heat that still reach Earth today. Earth travels around the Sun at an average distance of about 93 million miles, close enough for water to remain liquid, far enough to avoid boiling away. This position is sometimes called the habitable zone, a narrow region where conditions remain stable for long periods of time. While Earth moves around the Sun, it also rotates on its own axis, one slow turn every 24 hours. This rotation creates day and night, not as separate states, but as a continuous transition, light gradually giving way to darkness, and darkness slowly returning to light. The planet is surrounded by an atmosphere, a thin layer of gases held close by gravity, mostly nitrogen and oxygen, with traces of other elements. This atmosphere protects the surface from radiation, slows incoming meteors, and traps enough heat to keep temperatures relatively stable. Without it, Earth would be silent and frozen. Water plays a central role in Earth's story. Oceans cover more than 70% of the surface, storing heat, regulating climate, and supporting life. Water constantly moves through cycles, evaporating into the air, forming clouds, falling back as rain or snow, flowing through rivers, and returning to the sea. The same water has been circulating for billions of years. Deep beneath the surface, Earth remains active. Heat from its formation still moves through the mantle, slowly shifting massive plates of rock. Continents drift a few inches each year. Mountains rise, oceans widen. Earthquakes and volcanoes release pressure built up over long periods of time. These changes are slow, measured in millions of years, yet constant above the surface. The moon circles Earth once every 27 days, locked in a steady gravitational relationship. It stabilizes Earth's tilt, influences ocean tides, and keeps the planet's rotation regular. Without the moon, Earth's climate would be far more extreme, seasons less predictable. Earth's tilt, just over 23 degrees, is what creates seasons. As the planet moves around the Sun, different regions receive varying amounts of light. Summer and winter are not caused by distance from the Sun, but by the angle of sunlight striking the surface. This gentle variation shapes weather patterns and ecosystems across the planet. From space, Earth appears calm and unified. Blue oceans, white clouds, soft landforms, no visible borders. Astronauts often describe seeing Earth as fragile and complete at the same time. A single system moving through darkness. Beyond Earth, space opens outward in every direction. The solar system extends far past the outer planets, filled with icy objects, dust, and distant light. The nearest star beyond the Sun is over 4 light years away, meaning its light takes more than 4 years to reach Earth. Our galaxy, the Milky Way, contains hundreds of billions of stars, many with their own planets. It rotates slowly, completing one full turn roughly every 200 million years. Earth has orbited the galaxy many times since life first appeared, carried along quietly without disruption. The universe itself is vast beyond easy measurement. Galaxies drift apart as space expands. Light travels enormous distances, and yet, predictable laws guide motion. Gravity shapes structure, time moves forward evenly, and stability emerges from scale. This is the environment Earth exists within, a small planet in a wide solar system, inside a slowly rotating galaxy, part of an expanding universe, all moving together, all following gentle patterns that have lasted for billions of years. And this story will continue by moving farther outward, exploring stars, galaxies, and the deep structure of space before gradually returning closer again, following the same calm motion that carries Earth forward through the night. The Sun sits at the center of the solar system, a medium-sized star made mostly of hydrogen and helium. Every second, deep in its core, hydrogen atoms fuse into helium, releasing energy that travels outward as light and heat. This process has continued for more than 4 billion years, and it will continue for several billion more, providing a steady source of energy for the planets that circle it. Light from the Sun takes a little over 8 minutes to reach Earth, crossing empty space before touching the atmosphere. Some of this light is reflected back into space. Some is absorbed by land and ocean, warming the surface and driving winds and currents. Without sunlight, the planet would quickly lose its warmth, and life as we know it would not persist. Closest to the Sun are the rocky inner planets: Mercury, Venus, Earth, and Mars, each formed from heavier elements that could withstand higher temperatures. Mercury has almost no atmosphere and experiences extreme temperature changes. Venus developed a dense atmosphere that traps heat, creating surface temperatures hot enough to melt lead. Earth remained balanced, while Mars lost much of its atmosphere long ago, becoming cold and dry. These differences show how small changes in distance, atmosphere, and mass can shape an entire world. Earth's balance is not accidental. It is the result of many factors aligning over long periods of time. Beyond the inner planets lies the asteroid belt, a region filled with rocky remnants from the early solar system. These pieces never formed into a planet, likely because the gravity of nearby Jupiter disrupted their growth. Many asteroids have collided over time, breaking apart, reshaping, drifting slowly through space. Jupiter, the largest planet in the solar system, lies beyond the asteroid belt, a gas giant more massive than all other planets combined. Its gravity plays an important role, deflecting comets and asteroids that might otherwise travel toward the inner solar system. In this way, Jupiter acts as a distant guardian, shaping the paths of objects over millions of years. Saturn follows Jupiter, known for its wide ring system, made of ice and rock, each ring composed of countless small particles orbiting in precise paths. Saturn is less dense than water, meaning it would float if placed in a large enough ocean, a reminder that mass and volume do not always align in obvious ways. Farther out, Uranus and Neptune orbit in colder regions. Uranus rotates on its side, likely the result of an ancient collision, causing extreme seasons that last decades. Neptune experiences the fastest winds in the solar system, driven by internal heat rather than sunlight. Beyond these planets lies the Kuiper Belt, a vast region of icy bodies, including dwarf planets like Pluto, once considered the 9th planet, now understood as part of a larger population. Pluto's orbit is tilted and elongated, crossing Neptune's path without collision due to gravitational stability. Even farther, the Oort cloud surrounds the solar system at great distances, a spherical shell of icy objects. thought to be the source of long-period comets. These objects are so far away that sunlight is faint, and orbits take thousands of years to complete. The solar system exists within a bubble of space shaped by the sun's magnetic field, called the heliosphere. It shields the planets from some cosmic radiation, marking the boundary between solar influence and interstellar space. Beyond that boundary, space continues without markers, filled with thin gas, dust, and distant light, the same materials that once formed stars and planets, slowly moving under gravity. This larger environment remains calm, shaped by forces that act over immense timescales. Nothing rushes, nothing stops. Motion is steady and continuous. The solar system travels around the center of the Milky Way, carrying Earth along a path it has followed for hundreds of millions of years. And from here, the story will move outward again, beyond the solar system, into the structure of the galaxy itself, following the same slow and reliable motion that defines the universe. The Milky Way galaxy stretches across the sky as a faint band of light, a disk of stars rotating slowly around a dense center. It contains hundreds of billions of stars, along with clouds of gas and dust, all bound together by gravity. Our solar system sits in one of the outer spiral arms, far from the crowded core, in a region where stars are spaced widely apart, allowing long periods of stability. The galaxy completes one full rotation roughly every 200 to 250 million years. This period is sometimes called a galactic year. Since Earth formed, it has traveled around the galaxy more than 20 times, passing through regions of varying density without disruption. At the center of the Milky Way lies a supermassive black hole with a mass millions of times greater than the Sun. It does not pull everything inward. Instead, it acts as an anchor, helping organize the motion of stars around it. Black holes are not empty voids. They are regions where mass is compressed into an extremely small space, shaping gravity in powerful but predictable ways. Stars are born throughout the galaxy, forming in dense clouds of gas called nebulae. Gravity pulls material inward, pressure and temperature rise, and when conditions are right, nuclear fusion begins. A star ignites. Stars vary widely in size and lifespan. Some burn gently for trillions of years. Others shine intensely and burn out quickly, ending their lives in supernova explosions. Supernovae scatter heavy elements into space: carbon, oxygen, iron, the building blocks of planets and living systems. Every atom heavier than hydrogen was created inside a star. Earth itself formed from material recycled through earlier generations of stars, making the planet part of a much older cosmic process. Galaxies rarely exist alone. They form groups and clusters, bound together by gravity across vast distances. The Milky Way belongs to a small group of galaxies, including the Andromeda Galaxy, which is slowly approaching. Over billions of years, the two galaxies will merge, not in a collision of stars, but in a gradual blending, reshaping their structure while leaving most individual systems untouched. Between galaxies lies intergalactic space, extremely empty, yet not completely void. Faint traces of gas stretch across enormous distances, connecting galaxies like threads. This structure is sometimes described as the cosmic web, shaped by gravity acting on dark matter, an invisible form of mass that does not emit light, but influences motion throughout the universe. Dark matter makes up much of the universe's total mass. Its presence is inferred through gravitational effects, helping explain why galaxies rotate as they do and why large structures remain intact. Although it cannot be seen directly, its influence is steady and widespread, contributing to the universe's long-term stability on even larger scales. The universe itself is expanding, not because galaxies are moving through space, but because space itself is stretching. Distant galaxies appear to drift away from one another. The farther they are, the faster this separation occurs. This expansion has been ongoing since the universe began nearly 14 billion years ago. Despite this expansion, local systems remain bound. Galaxies, stars, and planets continue their orderly motion, guided by gravity. The universe evolves slowly, shaped by simple laws acting over immense time. Within this vast structure, Earth remains a small and steady presence, orbiting a single star, inside a spiral arm, part of a galaxy among billions. Yet conditions here remain calm enough for oceans to persist, atmospheres to endure, and life to continue. From this wide perspective, motion becomes gentle again, rotation, orbit, expansion, all unfolding without urgency. Nothing accelerates suddenly, nothing comes to an abrupt stop. The universe favors balance over speed, and the story will continue by gradually returning inward, moving from the scale of galaxies back toward stars, planets, and the quiet details of Earth itself, following the same slow paths that connect the largest structures to the smallest. From the scale of galaxies, attention begins to narrow again, not quickly, but along the same gradual paths that shape the universe itself. Stars remain scattered across wide distances, light traveling for thousands or millions of years before reaching another system. Space between them is calm, thin, almost empty, and yet full of motion at every scale. Stars like the sun are not fixed points. They move in long arcs around the galaxy, carrying their planets with them. Each planetary system is shaped by gravity, balance, and time. Most stars form with planets, disks of dust and gas flattening and gathering, collisions smoothing orbits, chaos slowly giving way to order. Our sun is one of many billions, not especially large or small, not unusually bright. Its stability is its defining feature. It changes very slowly, brightening gradually over billions of years, allowing long stretches of predictable conditions. This steadiness is one reason life on Earth had time to develop and adapt. Closer again, the solar system appears as a set of quiet paths, planets tracing smooth orbits, moons circling their worlds, everything guided by gravity alone, no engines, no corrections, just motion that has repeated for ages. Earth returns to view as a small sphere, turning steadily, half in light, half in shadow, clouds forming and dissolving, oceans reflecting faint starlight on the night side, lightning flickering briefly, then fading, all surface activity balanced by the planet's mass and rotation. The atmosphere remains thin when seen from space, a narrow blue edge hugging the planet. This fragile layer contains nearly all the air, weather, and protection life depends on. It circulates constantly, redistributing heat from equator to poles, smoothing temperature differences, preventing extremes. Below the clouds, land and sea continue their slow interaction, erosion shaping mountains, rivers carrying minerals to the ocean, sediments settling into layers, later to be lifted again by tectonic forces. Nothing here is final, but nothing changes quickly either. Earth's magnetic field extends far into space, generated by the movement of molten iron in the core. This invisible shield deflects charged particles from the sun, preventing the atmosphere from being stripped away. Occasionally, these particles slip through near the poles, creating auroras, slow curtains of light moving across the sky. visible reminders of the connection between Earth and space. The rotation of the planet remains steady, nights and days following one another in sequence. Biological systems adapted to this rhythm, plants responding to light, animals to temperature, human bodies to cycles of rest and activity, all aligned with the planet's motion. The surface may feel still, but Earth carries everything along, through space, around the sun, around the galaxy, and through the expanding universe, without disruption, without awareness. This motion does not require attention. It continues whether observed or not. At this scale, the universe feels less distant, its patterns reflected in smaller systems, rotation, orbit, balance, repetition. The same principles apply from galaxies to planets to the slow turning of the Earth beneath the night sky. And the story continues by moving even closer toward the details of Earth itself, its history, its rhythms, and the quiet processes that unfold on a planet that has traveled through space for billions of years, steadily, reliably, and without pause. Earth has carried water for most of its history, oceans forming early, remaining liquid through cycles of warming and cooling. Water absorbs and releases heat slowly, acting as a stabilizer for the planet's climate. Currents move warmth across vast distances, connecting regions that would otherwise drift toward extremes. The Gulf Stream, for example, transports heat from the tropics toward the North Atlantic, shaping weather patterns far from the equator. The continents you know today were once joined together, assembled into a supercontinent called Pangaea, over hundreds of millions of years. Tectonic plates slowly separated, opening oceans, redirecting currents, altering climates. Life adapted gradually to these changes, spreading, diversifying, settling into new environments. Earth's crust is divided into several large plates and many smaller ones. They move only a few centimeters each year, but their interactions create mountains, trenches, earthquakes, and volcanoes. The Himalayas continue to rise as India presses into Asia, while the Atlantic Ocean widens slowly as plates pull apart. These movements are quiet on a human timescale, yet powerful across geological time. Beneath the crust lies the mantle, a thick layer of hot, slowly flowing rock. Heat moves upward through convection, driving plate motion above. Deeper still, the core remains extremely hot, composed mainly of iron and nickel. Its movement generates the magnetic field that surrounds the planet, invisible, steady, protective. This magnetic field extends far beyond the atmosphere, forming a region called the magnetosphere. It deflects most of the solar wind, a stream of charged particles flowing outward from the sun. Without this protection, Earth's atmosphere would gradually erode, as happened on Mars, where the magnetic field weakened long ago. Life on Earth developed under these stable conditions, first as simple cells in the oceans, then gradually becoming more complex. Photosynthetic organisms released oxygen into the atmosphere, slowly transforming it, creating the conditions for more energy-intensive life. This change took hundreds of millions of years, yet once established, it reshaped the planet permanently. Oxygen allowed the formation of the ozone layer, which absorbs harmful ultraviolet radiation, adding another layer of protection at the surface. This allowed life to move onto land, spreading across continents, adapting to light, gravity, temperature, and seasonal change. The length of a day has not always been 24 hours. Early in Earth's history, rotation was faster, days were shorter. The slowing occurred gradually, influenced by interactions with the moon, tidal forces transferring energy, stretching time gently, predictably, over billions of years. The moon itself formed early, likely from debris after a collision between Earth and a Mars-sized object. Material gathered, cooled, and settled into orbit over time. The moon stabilized Earth's rotation, reducing chaotic wobble, making long-term climate stability possible. Ice ages have come and gone, driven by small variations in orbit, tilt, and rotation, known as Milankovitch cycles. These slow changes alter how sunlight reaches different latitudes, advancing and retreating glaciers, reshaping landscapes, carving valleys, redistributing water, all without urgency, following rhythms measured in tens of thousands of years. Despite these shifts, Earth has remained within a narrow range of temperatures for most of its existence, warm enough for liquid water, cool enough to avoid runaway heating. This balance is delicate, yet resilient, maintained by feedback systems involving clouds, oceans, ice, and living organisms. At night, when the sunlit side turns away, Earth radiates heat back into space, slowly, evenly, preventing overheating. The atmosphere controls how quickly this heat escapes. Another quiet adjustment in an ongoing exchange between planet and space. From this perspective, Earth is not static, but it is steady, shaped by slow forces, guided by predictable laws, and carried forward through the universe without disruption. Every rotation, every orbit, every geological shift follows patterns that have held for immense spans of time, moving gently through Earth's rhythms, its cycles of motion and change, before eventually widening once more to the larger universe that holds this small, enduring planet in place. Earth's surface is shaped not only by forces from within, but also by energy arriving from space. Sunlight reaches different regions at different angles, spreading evenly near the equator and more gently toward the poles. This uneven distribution drives winds and ocean currents. Air warms, rises, cools, and moves again, creating large circulation patterns that repeat year after year. The atmosphere is layered. Closest to the surface is the troposphere, where clouds form and weather occurs. Above it lies the stratosphere, calm and stable, containing the ozone layer that absorbs much of the sun's ultraviolet radiation. Higher still, the air thins further, gradually blending into space. These layers work together quietly, filtering light, regulating temperature, and allowing life to remain close to the surface. Oceans respond slowly to change, absorbing heat during warm periods, releasing it during cooler ones. This delayed response smooths temperature shifts over long periods. Deep ocean currents move water around the globe over hundreds or even thousands of years, connecting distant regions through a slow planetary circulation. Salt in the oceans plays an important role. Dissolved minerals increase density, affecting how water sinks and rises. Cold, salty water near the poles sinks toward the ocean floor, while warmer water rises elsewhere. This movement helps transport nutrients, oxygen, and heat, supporting marine ecosystems far below the surface. Earth's surface reflects some sunlight back into space. Ice and snow reflect more. Darker oceans and forests absorb more. This balance affects global temperature. When ice expands, more sunlight is reflected, cooling the planet further. When ice retreats, more heat is absorbed. Warming continues. These feedbacks unfold gradually, shaping climate over long timescales. Living organisms participate in planetary cycles. Plants absorb carbon dioxide and release oxygen. Oceans exchange gases with the atmosphere. Soil stores carbon for centuries. These processes regulate atmospheric composition, maintaining conditions that remain relatively stable despite constant change. The carbon cycle moves slowly. Carbon travels from atmosphere to ocean, into living organisms, into rock, and back again through volcanic activity. Some carbon atoms take millions of years to complete a full cycle, passing through multiple forms before returning to the air. Earth's orbit is not a perfect circle. It stretches slightly, becoming more round, then more elongated, over long periods. This subtle variation influences climate gently, never abruptly, allowing systems time to adapt. The planet's tilt also shifts slightly over tens of thousands of years, changing how seasons contrast. When tilt increases, summers grow warmer and winters colder. When it decreases, seasonal differences soften. These variations are small, but persistent, shaping ice ages and interglacial periods without sudden transitions. Earth's rotation remains steady, but not rigid. Small changes occur due to shifting mass, melting ice, moving water, earthquakes. These adjustments are tiny, measured in milliseconds, yet carefully tracked, demonstrating how sensitive and interconnected planetary systems are. The night side of Earth is never completely dark. City lights glow faintly, lightning flashes briefly, auroras ripple near the poles, and moonlight reflects off clouds and oceans. Even in darkness, motion and energy continue, quietly, predictably, from far away. Earth's signals blend into background noise, a faint radio signature, subtle atmospheric patterns, indistinguishable among billions of worlds. Yet here, on this one planet, conditions remain balanced enough for oceans, weather, and life to persist together. The universe does not single Earth out. It simply allows conditions where stability can emerge. Given time, balance forms, and once established, it can last for billions of years. And so the story continues, following the slow movements of a planet shaped by light, gravity, water, and time, carried forward through space, steady and enduring beneath a wide and quiet universe. Over long stretches of time, Earth's surface records its own history. Layers of sediment settle, compress, and harden into rock, each layer holding information about temperature, atmosphere, and life from a specific era. These layers accumulate slowly, millimeter by millimeter, creating a deep archive beneath the ground. Fossils form rarely, requiring precise conditions. An organism must be buried quickly, protected from decay, and preserved as minerals replace organic material. Most life leaves no trace at all, yet enough remains to show a gradual unfolding. Simple forms first, then increasing complexity, spreading into many environments, adapting to changing conditions over immense spans of time. Extinction events have occurred throughout Earth's history, often triggered by volcanic activity, climate shifts, or impacts from space. These events unfold over thousands or millions of years, clearing ecological space, allowing new forms of life to emerge. Recovery follows slowly, diversity returning in new patterns, shaped by altered environments. One such impact occurred about 66 million years ago, when a large asteroid struck near what is now the Yucatan Peninsula. The energy released altered climate worldwide. Many species disappeared, while others survived and adapted. This was not an end, but a transition, part of a long sequence of change and renewal. Through all these shifts, Earth maintained its fundamental balance. Oceans remained liquid, gravity held the atmosphere, rotation continued, and the planet kept moving along its orbit. Disruptions never stopped motion. They reshaped conditions, then gave way to new stability. Life eventually reached every surface environment: oceans, land, air, and even extreme conditions such as deep-sea vents and polar ice. Each adaptation relied on energy from the sun, chemical gradients, and time. Evolution proceeds without planning, guided by variation and persistence rather than direction. The night sky above Earth has also changed. Stars slowly shift positions over thousands of years. Constellations are temporary patterns, visible only during certain eras. The North Star changes as Earth's axis slowly wobbles, tracing a circle over 26,000 years. The stars visible tonight are at many different distances. Some light began its journey before human history, some before Earth itself formed, yet all arrives together, layered in time, forming a calm and steady backdrop. Meteorites occasionally enter the atmosphere. Most burn away quietly, streaks of light lasting only seconds, delivering material from beyond Earth, small reminders of the wider environment through which the planet travels. Space around Earth remains active. Satellites orbit silently. Debris follows predictable paths. Gravity keeps order. Even in near-Earth space, motion remains regulated. Earth's future will continue to follow these slow patterns. The sun will gradually brighten. Continents will shift further. Oceans will change shape. Ice will advance and retreat. None of this occurs suddenly. Each change unfolds over spans far longer than individual lifetimes. Far in the future, billions of years from now, the sun will expand, altering conditions. Yet even this transition will occur slowly, giving time for adjustment. Time remains the constant factor in every cosmic process. For now, Earth continues its quiet passage, rotating, orbiting, exchanging energy with space, maintaining balance through countless interactions. The same forces that shaped the planet long ago remain active, steady, predictable, and this story will continue to unfold, moving gently between Earth and the wider universe, following cycles that repeat, shift, and settle again, guided always by gravity, motion, and time, under a sky that remains vast, calm, and enduring. Over the long night of the universe, Earth remains part of a larger rhythm that never truly pauses. The planet follows paths set by gravity, energy, and time, not choosing direction, only responding to forces that have acted since its formation. The stars above Earth appear fixed from night to night, yet they are all moving, each one following its own orbit around the galaxy, some slowly drifting apart, others bound together in clusters. Their motion is so gradual that change is almost imperceptible. Stability emerging from constant movement. Light continues to travel across space, not quickly, but steadily, carrying information from distant regions. When that light reaches Earth, it interacts gently with the atmosphere, scattering, softening, turning harsh radiation into warmth and illumination. The sky itself is shaped by this interaction. Blue during the day, dark and deep at night. The darkness of space is not empty. It holds faint radiation left over from the early universe, a quiet background glow present everywhere. This cosmic background has cooled over billions of years, stretching as space expands, a reminder that the universe has a history and that it has been slowly changing since its beginning. Earth exists comfortably within this expanding space. Local gravity holds the planet in place, while the larger universe stretches outward. These two motions coexist without conflict. Small systems remain stable even as the larger structure evolves. Time flows evenly across these scales. Seconds pass on Earth, years pass in orbits. Millions of years shape geology. Billions of years shape stars and galaxies. Each scale has its own pace, none rushing, none resisting. The materials that make up Earth, iron, oxygen, silicon, carbon, were once scattered across space, formed inside stars, released by stellar winds and explosions, gathered slowly into clouds, then into planets. The matter beneath your feet has traveled across the galaxy before becoming part of this world. Even now, Earth continues to receive material from space. Microscopic dust falls through the atmosphere each day, remnants of comets and asteroids, most of it unnoticed, adding quietly to the planet over time. The atmosphere breathes in response to sunlight and rotation. Pressure systems shift, clouds form and dissolve, winds move heat gently across the surface. None of this is directed. It emerges naturally from physical laws. Beneath the oceans, deep currents continue their slow circuits, taking centuries to complete a full path, redistributing energy and nutrients, shaping climate without drama. The surface may change quickly, but the deep ocean remains patient. Life on Earth moves within these rhythms, responding to light, temperature, and gravity. Biological clocks align with planetary motion. Cells divide, repair, and renew in patterns shaped by day and night, season and cycle. Yet Earth does not require life to continue its motion. It carried oceans and continents long before life appeared, and it will continue to rotate and orbit long after individual forms change. The planet remains steady regardless of who observes it. From this perspective, Earth is neither fragile nor invincible. It is resilient within certain bounds, stable because it is part of a much larger system that favors balance over extremes, and so the universe continues, not as a place of sudden events, but as a landscape of slow processes, gradual shifts, and repeating cycles. Stars form and fade, planets assemble and evolve, galaxies drift and merge, all without urgency. Within this vast and patient structure, Earth follows its familiar path, a small world turning gently, carried forward by forces that have never hurried, under a universe that remains wide, quiet, and endlessly unfolding. The universe does not move with intention, yet it follows patterns that repeat with remarkable consistency. Gravity pulls matter together, motion carries it forward, energy spreads and redistributes. Nothing resists these processes. They unfold naturally, shaping everything from the smallest particle to the largest structure. Earth exists comfortably within these patterns. Its mass holds it together. Its rotation distributes light and warmth. Its orbit remains stable. Even small variations occur gradually, allowing systems time to adjust. This slow pace is what makes long continuity possible. The night sky above Earth appears calm, stars scattered across darkness, yet each point of light represents immense energy released over long periods. Many stars visible to the eye have already changed or faded. Their light continues on, arriving long after its source has shifted. Time and distance overlap quietly here. The moon continues its path around Earth, maintaining a steady distance, drifting away at about the speed fingernails grow. This gradual separation lengthens days imperceptibly, stretching time gently, without disruption. Earth's oceans respond to the moon's pull. Tides rise and fall twice each day, not as waves, but as broad movements of water across the planet. This motion mixes nutrients, influences coastlines, and has done so since the oceans first formed. Even the rocks beneath continents move slowly. Pressure builds, releases, reshapes landscapes over millions of years. Nothing sudden from this scale, only long-term transformation. Space around Earth remains filled with quiet signals, radio waves from distant stars, faint cosmic radiation, particles from the sun. Most pass through unnoticed, filtered by atmosphere and magnetic field. allowing the surface to remain calm. The laws that guide all of this do not change. Gravity behaves the same across space. Light travels at a constant speed. Energy follows predictable paths. This consistency allows complexity to emerge. Stars form, planets stabilize, environments persist. Earth's position within this structure is temporary, but not brief. Billions of years represent a stable window, long enough for oceans to remain, climates to cycle, and intricate systems to develop. The planet continues forward, turning through night, moving through space, exchanging energy with its surroundings, every moment connected to the one before. No sharp edges between past and future, only gradual transition. And as the universe continues its slow expansion, Earth remains part of a local system that holds together. Gravity binding stars, stars binding planets, motion remaining smooth, uninterrupted. This is how the universe sustains calm, not by stopping motion, but by spreading it evenly across time, allowing change to occur without urgency, without noise. Earth follows this same approach, enduring through balance rather than force, adapting through slow shifts rather than sudden turns, carried forward under a sky that never rushes, never pauses, only continues. And the story remains open, unfolding gently as Earth moves on, quietly, steadily, within a universe shaped by patience, rhythm, and time. The story of Earth and the universe continues on its own, without words, without attention. The planet keeps turning, the stars keep their distance, and space remains wide and calm. Nothing needs to be followed any longer. Everything moves as it always has, steady and quiet. You can let the story fade now, knowing that these vast patterns will continue through the night and far beyond it.